Welcome back, everybody. I heard from our mentors who were with you in the breakout rooms that we are busy building and designing our amazing bridges. But this is your time now. You can keep working, but we have two mentors who are going to lead a live Q&A session. And this is your opportunity to have, I know there's a lot of classroom setups today, so please type in chat, have your teachers come up to the computers to type in chat some questions for our mentors. I'm going to stop speaking and let them introduce themselves and tell you guys a little bit about their background, but please do not hesitate. We love when you guys have some questions for them. So Bryce and Dylan, take it away. I see Dylan is off mute, so I'm going to hand it off to Dylan first.
All right, awesome. So I'm going to go ahead and share my screen with our slides. So to start us off, my name is Dylan. I'm a sophomore. I just finished my sophomore year, as I told you in the breakout room. I'm going into my junior year now at the University of Notre Dame. I'm a computer science major, so when we get to that, once we stop introducing ourselves, we'll get to Q&A, and you can ask me questions about coding, computer science, anything along those lines. So I've been doing labs like this and doing Q&A sessions like this since about October. And my interest in engineering includes software engineering, artificial intelligence, and machine learning. So a little bit about me and my kind of experience with college and engineering and kind of my path from there. I went to an all-girls Catholic high school from 2017 to 2021. So I was a high school grad of the class of 21. Some cool engineering experiences I did in high school. When I was in high school, I kind of didn't know as a freshman what I wanted to do. And then I kind of got involved in robotics as a freshman. And that kind of introduced me to the world of engineering and why I wanted to become an engineer. So I started with pretty much no experience and then became part of that robotics team. And some later experiences I had, which I'll talk a little bit about too. I live in New York, so I'm very close to New York City. And there was a program called Perry Outreach Biomedical Engineering. It was like kind of a one-day experience where we got to go talk to doctors, biomedical engineers, kind of anyone involved within the cross-section between medicine and engineering. And we got to do a lot of really cool activities and do Q&A and talk to a bunch of people who are involved in biomedical engineering. Like I also said, I was, by my junior year, I was the captain of the varsity robotics team at my high school. So it kind of sounds silly. It's like varsity and JV, but so I started off as the JV captain my sophomore year, and then my junior and senior year, I was the varsity team captain. So we went to competitions, we built robots and went to competitions. And then I was also the introductory coding club founder and president at my high school. So we didn't really have like I think they had an AP computer science class, but sorry, my computer's dying. Let me just plug that in. We didn't really have a AP computer science, or we didn't have like a club for introducing people who didn't know much about coding. So I was able to kind of create that and kind of bring coding to the girls at my school. And then once I graduated high school, I began attending the University of Notre Dame. So some cool experiences I had with engineering at Notre Dame. So like I said, I'm a computer science major. I started off as aerospace engineering, but my freshman year, I worked on an animatronics workshop. I was a student lead for this project where we were bringing animatronics and kind of that interest in the cross section between computer science and mechanical engineering to a bunch of students in local schools and local day camps. So I worked alongside a Notre Dame professor who was interested in the field, and also he used to work at Disney, but we worked with someone who worked with Disney Imagineering. So if you don't know what Disney Imagineering is, it's basically where they kind of work together there's a bunch of different sides of it, but they basically work on bringing kind of that magic of Disney to life and kind of making it, animatronics and visual effects and things along those lines. So I got to actually work with someone who worked at Disney, who knew my professor and had that connection. So I was able to work on that project, which was super cool, especially because I did the robotics stuff. That kind of got me excited about the animatronics stuff, because it was kind of taking the more like bare bones robotics and making it into something more friendly and more approachable, which was really cool. And then during my sophomore year, so this past year, I was very involved in the Girls Who Code program. So we didn't have a program at my school for Girls Who Code. We had a club for women in computer science, but not specifically Girls Who Code, which I think is a really cool program that is really important to get involved in if it's like a big national kind of club that people can get involved in at any age. There's things for events for kids who are in elementary school, middle school, high school, and then also college loops. So that's what I kind of started at Notre Dame. So I was able to bring that cool experience of bringing Girls Who Code to Notre Dame. And then also, so this summer, this upcoming summer, I'm doing research on campus at Notre Dame. I'm working with a professor who recently showed interest in getting undergrad researchers, undergrad researchers. So basically it's called the Summer REU, which is a research experience for undergrads. It's specifically when they have funding for undergrad students who are interested in doing research. So I'm doing research on machine learning and artificial intelligence, and those are kind of two things that, I'm not entirely sure what I want to do with computer science yet, but they're two big options that I could go into. So I'm excited to do some research on that. So a little bit about my experience. So the top left two pictures, there's a picture of me at that Perry Outreach Biomedical Engineering program. So if you have any interest in that, there might be programs nearby at hospitals or places near your school that might have programs where you're able to do that. So I have a picture of me with a cast that my friend was able to put on me, and then I was able to put a cast on my friend, which was really cool, and kind of seeing how those materials work and why it's important to think about how those materials are going to work and be comfortable for a patient who needs to have a cast. Next to it is a picture of me with my robot. So if you can see, I'm in the blue shirt, and then next to me is the robot that I created. That was I think my sophomore year robot. So that was my JV team, and we ended up winning a trophy for that, which was really cool. It was the first robotics trophy that my school had ever won, which was really exciting. The second picture shows, like after the first arrow, it's a little jumbled, but after the first arrow is a picture of me working at the animatronics workshop that we had. So we spent a lot of time planning this event where we were able to create a little paper animatronics and show them to elementary schoolers, which was really exciting. They were really excited about it, and they were able to record their own voice, record sounds, make their animatronic talk, make the mouth move, make the hands move, which was really exciting. So kind of getting that motion of making sure that the animatronics were able to work was really cool. I talked a little bit about this in the breakout room, but I did a study abroad program over the summer in London, where I was able to take 2 classes with the University of Notre Dame. We have a global gateway program in London, so I was able to study abroad there, which was really exciting. And then the bottom jumble of pictures is just a bunch of stuff I've done in some of my classes. I was trying to find pictures of code that I had in my camera roll. And as I was going through, I found like the middle picture, the big one with a bunch of little pictures of code. It just showed a big chunk of code that I kept taking pictures of, because I kept, trying to work on it and trying to figure out and look at old types of code that I did. So just a bit of an example of what my code kind of looks like, and kind of how much I have to do with that as a computer science major. I love coding, and I didn't think I really would have loved it that much in high school, but once I got to college, I kind of discovered that love again for coding, and that's kind of where I'm at now. On the bottom right-hand side, also I have a picture of, if you're interested in like computer engineering or electrical engineering, a little bit about like a circuit board that I was working on in a class I had this semester. But now I will pass it off to Bryce.
Hey everyone, good morning. So my name is Bryce and I'm a rising junior at the University of Mississippi. I'm studying general engineering with a manufacturing emphasis. So at Ole Miss, if you're studying general engineering, you can choose from a number of different emphases. So it's I think manufacturing emphasis, a business emphasis, an aerospace emphasis. I chose manufacturing. I'll get into that definitely a little bit more later. My involvement with Engineering Tomorrow, I am a college mentor. I've been a college mentor for over a year now. And then last summer, I got to work on developing a in-person manufacturing lab that I believe was actually like sent out and distributed this year. So that's very exciting. And then my interest in engineering, I'm involved in the Center for Manufacturing Excellence, the CME. I'll talk a lot more about that, the Society for Women Engineers, and then I'm interested in either working in the industry or on the corporate side of engineering. So if any of you guys have any questions at any point about that, I can definitely answer those for you guys. But I'll go ahead and just talk a little bit about my timeline now. So I also actually, funny enough, went to an all-girls Catholic high school. And I went from 2017 to 2021. So I graduated class of 2021. And it was really great because at my high school, I was lucky enough to take 4 years of engineering classes. So engineering was actually built into my high school curriculum. And I also was able to get involved in a couple of different engineering clubs. So we also had robotics club. I was able to get involved in that. We had different coding competitions. We had Girls Who Code at my high school, and I was able to get involved in that. And so that's kind of how I knew that I wanted to be an engineer. I was lucky enough to get to take those classes in high school and kind of get a little bit of exposure to engineering before diving into it headfirst in college. And you can see I just have some bolded stuff here. I also was able to get some leadership positions in some of these clubs. So kind of like Dylan, you were talking about president of the varsity robotics team. I was able to kind of work with like different faculty and different teachers with on the robotics team as well. So that was very exciting. And then my freshman year, I went to Ole Miss, obviously, and I actually started as a chemical engineer because I really liked chemistry. I really liked engineering, and I was like, why not combine the two and see what happens? And it definitely wasn't for me. I ended up just changing my major to general engineering with a manufacturing emphasis after my freshman year, just because I didn't really want to be too focused on just chemical engineering, because that kind of limited my options going into the workforce. And so because I'm a general engineer, I'm able to take a bunch of different classes. So I'm taking like electric circuit theory. I'm taking a class on bridges. I took a class on bridges. So that's funny. You guys are building those right now. And then my sophomore year, I was actually lucky enough to get a lot of industry experience through the Center for Manufacturing Excellence, or the CME. And so this year I went to Nissan in Jackson, Mississippi, and also another smaller manufacturing plant called ADP in Grenada, Mississippi. And basically what that was is I was just able to get some hands-on industry experience, go out on the factory floor and solve some real problems that were actually happening on the floor. And I also started taking more specialized classes for my interests. So you guys will see when you're going through engineering, you'll start out kind of general, and then you'll narrowly like broaden down, or you'll start out general and then you'll like focus in more on like what you're specializing in. And then my senior year, I'm hoping to get some internships. So I don't know why my slide didn't update, but I had some pictures of some other companies that the CME actually works with and does partnerships with. So we do partnerships with Raytheon, with Toyota, with Milwaukee, with Continental. And so what the CME will do is they will bring in representatives from these companies to talk and eat lunch with a group of students that are maybe interested in working there that summer. And that way we're really able to get like a personal connection with those representatives. And so hopefully I'll be able to get some real world competitive experience my junior and senior year. And I can apply what I've learned in my manufacturing classes into some real life situations. All right, so like I said, I'm going to talk a little bit more about why I chose to do manufacturing. I really liked that it was very hands-on, it was very interactive, but I also realized that there was a lot of opportunity for manufacturing, because if you think about it, everything that you've ever used ever has to be manufactured somehow, right? And so either on a factory floor, an assembly line, or just like robotically. And so these are some pictures that I've taken in my time at industry, spent at industry. So the first one all the way to the left on the top, that is actually at Advanced Distributor Products. And I was actually there a little bit less than 2 weeks ago, actually. And so basically what we got to do is we got to go out and look at a certain portion of the assembly line. And our team was responsible with identifying problems and thinking of ways that we can solve those issues. And then we were actually able to present our presentation to the senior executive board of the company, which was really cool. And they just like kind of seeing how our solutions can be implemented and end up saving the company a lot of money. That middle picture is my team and I at Nissan. So Nissan, obviously they produce a lot of cars. So we didn't really do as much work out on the floor at Nissan, just because it's such a huge manufacturing plant. That was kind of more just learning about different manufacturing like procedures and things like that, like manufacturing ways of thinking. But that is actually us out on the trading room floor. And then the picture on the top right is also at Nissan. And so you can see you're kind of just like working on building cars and like learning the way of like an assembly line without actually like being on the floor manufacturing huge cars. And then that bottom picture, that is at ADP Products. So you can see we had to have our full protective gear on. So we had our orange traffic cone vests, and we had to wear safety goggles and earplugs. And then when we went out on the floor, we had to wear full long sleeves and gloves, because everything we were working with was either hot or sharp. And so it's pretty cool. I've been able to get some really incredible industry experiences through the Center for Manufacturing Excellence at Ole Miss, and just in general manufacturing experience, because that's definitely very valuable when you're looking to work in the field. It's just kind of having some experience and learning a little bit more about what you're actually going to be doing rather than just diving in head first. So that's a little bit about my background. And if you guys have any questions at any point during the rest of the Q&A, we can definitely answer those for you.
Well, I know that one question came in while you guys were doing your introduction, and I think both of you might be able to answer this question is which language do you mostly use to code and design?
Yeah, so for me, I use a variety of languages. I think it's important to kind of be versatile in a bunch of different coding languages. Um, for me, this past semester, we used a mix of Python and C. So throughout my time here, I think we started off with learning MATLAB because I think it's a pretty general language that a lot of engineers will end up using. I know my friends who are doing like mechanical engineering or civil engineering. I think a couple of them have used MATLAB before. So it's kind of like not as well known necessarily in the computer science world, but it's pretty important for just like in general for engineers to know with MATLAB. They use it a lot with like 3D printing and stuff like that, I think, and making apps for specifically for different types of projects. With computer science, at least, um, I've used C and Python the most. I think I learned a little bit also about shell scripting in a terminal. If you don't know what that is, it's just like a very like low level language where it's kind of like bare bones, kind of more like a skeleton language, if that makes any sense. Um, but with Python, it's very like high level language. It's learning a lot about, you're able to do a lot more without putting a lot of thought into it. I think it's very, if you wanna do something, you kind of just have to type it out, and it's kind of very basic in terms of the format and the words you use, the indenting and everything is a lot more intuitive than maybe with something like C, where there's a lot more like connections you have to make, and you have to make it a little more complex. Um, but I think personally, I like Python the most. I'm trying to teach myself a couple extra languages too that I've heard from engineers in industry or computer scientists in industry. I think there's a couple other languages. I know a lot of people do Java. We didn't really do Java at Notre Dame. I don't think I'm going to do much Java at Notre Dame. I know a lot of people will learn that in high school with like AP computer science. But the cool thing about knowing a language is it's pretty easy to transition to a different language in computer science. And with coding, I think it's definitely really cool to kind of be able to go from one language to the next and kind of see those similarities, but also recognize that there's going to be differences that make different functions and different algorithms easier to implement based on the language you're using. That was a great question.
That really was really a great question. And I took a very basic, like all engineers at Ole Miss are required to take a very like basic computer science class. And we just kind of coded with Microsoft, and we were looking at how to like formulate different spreadsheets and like calculations and stuff like that. So my coding experience is definitely more limited than yours, Dylan, but I've been able to do a little bit just because I feel like it's so valuable to have in the engineering workforce. So I see we have another question came in. Someone asked, oh, I just went away, but I think
So we actually polled the students before the session, and they submitted some questions via a Google form. And one of the questions that came in from Mercy Academy in Louisville, Kentucky was, what high school courses prepared you most for college?
Yeah, that's a really great question. And I think that in general, high school courses are just going to be a little bit different than college courses, not even just the material, but just the way that your day is structured. So like for high school or for high school classes, obviously you meet every single day for like 1 hour, 45 minutes, however long your block schedule is. But in college, you usually only meet 2 or 3 times a week, usually for about an hour. And then you spend a lot more time working outside of class and studying and learning the material outside of class. So definitely like the biggest adjustment for me was the timing change. I was like, well, like I'm not in class right now. What am I like? I don't have to do any work. But I think that when you're in college, like the big part of having those classes meet less is knowing that you're going to be putting in independent work. And that's definitely something that I've had to learn. But kind of like what I talked about, I was lucky enough to take engineering classes in high school, and just kind of being introduced to that material very early on in my education definitely helped me prepare for college and kind of learn more about what I was getting myself into, rather than just, saying, oh, I want to study engineering and not really knowing what I was actually going to be studying. And that's why it's great you guys get to do these labs too, to get some, some limited exposure to the engineering world. Ultimately, you can decide if it's something that you enjoy or not, and then continue to pursue it. So definitely my engineering classes have helped me the most with the material itself, just like I said, learning the basics. But every high school is a little bit different. So Dylan, what about you? Did you have any classes that like really prepared you, would you say?
Yeah, I think definitely at least freshman year of college, I thought that all of my AP classes really prepared me, because you might take an AP class hoping to get credit, but based on the school you go to, you might not get credit for that specific type of class. So definitely, looking at the colleges you're looking at, look at what schools are going to take what AP credits or IB credits. My school just had APs, but I think those AP classes, just the format of those classes, really prepared me for kind of that rigor that you're going to get in college. It's a little more rigorous than your like regular level classes that you'll be taking in high school. So definitely those AP classes are going to be important for me. I think specifically the AP physics and AP chemistry classes. I took both of those. I did 2 sciences my junior year of high school. And I think just the background knowledge I got from those classes really helped me with the basic engineering classes that everyone takes. So again, your general chemistry class, your general physics class. I think going into those classes with that background knowledge is going to be really useful, and kind of using that knowledge you took in high school to make your schedule freshman year a little easier once you get to college. For me, those 2 classes specifically stood out. I think also just taking any AP classes that might get credit too. I know I took AP Lang, and that gave me the opportunity to kind of lighten my schedule because I was able to get that credit, and gave me some more options for what my schedule might look like later on. So right now, between the AP credit I had and also the summer courses I took when I studied abroad in London, I have a lot more space in my schedule to kind of make my schedule look how I want it. So making sure that you're able to kind of maximize what your schedule is going to look like and make it kind of more specific to you and what you're interested in. I think definitely taking those AP classes is going to help prepare you, as well as kind of maybe make your load a little easier once you get to college. And if you have again, those higher level classes, like the IB classes, I don't know much about IB, but if your school offers that too, definitely consider taking those. I think also, aside from classes, just kind of getting involved in if you're interested in a specific type of, whether it's engineering or anything else, like if it's business too, just getting involved in clubs or activities at your high school, for sure. I think it was what pushed me towards engineering, like I said, with that robotics stuff. Getting involved in those clubs was kind of what told me I want to be an engineer. So definitely looking at within your school clubs, activities, events, also outside of your school. So if you get emails, or if you're on an email list that might seem kind of annoying, but you get emails about events that are going on in your town, in your region, in your area, things to apply for, just apply. You don't have to do it. If you get it, you don't have to do it, but definitely getting involved in things that you're interested in, and kind of exploring your interest within engineering itself is really important in high school.
That is great advice about keeping your options open, right? Dylan, great advice. So we have a
Yeah, for
question
sure.
from Ballou High School in DC, which is taking us back to our topic. It asks, what environmental conditions are taken into account when designing bridges?
I would say all environmental conditions. Pretty much you need to consider everything, whether it's the weather, kind of the way the land is laid out and what you're building it on, what type of material you're putting your edges of your bridge on, if you have supports underneath, is it over water, is it over land, kind of all of those environmental conditions are going to be important. Weather is going to be important based on the materials you use, and some of those I know my friend who's a mechanical engineer and my civil engineering friends took a materials engineering class where they were able to learn about what materials are good to use in what situations. So definitely considering, the different types of concrete you could use, different materials you could use, different types of metal you could use. All of those are going to be really important for considering, where you're going to be building your bridge, looking at the kind of layout of where you're putting things and how it's all going to come together. You got to kind of take in everything. I don't know, Bryce, do you have anything to add to that?
Yeah, I was just gonna say kind of what you said, obviously if it's super windy, that has to be taken into account. If it's being built higher up, how long the bridge is, where it is, all that stuff kind of just has to be taken into consideration. And I see we have a few raised hands.
I was just going to hop to Middle College was the first one that hopped up there, and they actually shared a bridge with us, and they're asking for our mentors to provide them with some pointers. So I'm actually going to spotlight this Middle College right now for everybody to see. And Bryce, Dylan, do we have some pointers for this amazing bridge?
Yeah, I think that looks amazing. And I really like how you guys kind of implemented those triangle shapes. And I know I saw some bridges in the breakout room and we talked about kind of symmetry and how that can also help with your bridge. And I mean, I think that that looks awesome. One thing that you can even consider is trying, even if like how, just to, or think about is if you were going to make it longer, how you would adjust your design, or like say, kind of just like push down in the center so and see kind of how the forces impact the bridge. And so I know like one thing that I did when I went through this lab to test the bridge is I actually tested pushing down from the top of the bridge and also like pulling down from underneath, because you're going to have both of those forces kind of working simultaneously at the same time. And you want to make sure that your bridge can withstand both of those things. And also even just adding some support like underneath. So like maybe it's going to be like freestanding, like maybe you get like some beams and you can just like add some more popsicle sticks underneath and you can actually like test it out. That would be really, really cool. But I mean, I think that looks great. I love your guys' design. I think you did a really great job. Dylan, do you have any feedback for them?
Yeah, I mean, I love the truss shape. I always recommend the truss because I think it's just such a cool design to make, and it makes your design really strong. So making sure the kind of connections between your popsicle sticks there might be important. Making sure that there's no inconsistencies in how well stuck together they are, if that makes sense. And like Bryce said, I always recommend like pushing down. Just put a little bit of force with your hand to see maybe where some of those you might need some reinforcements. So just kind of getting an idea of, are the popsicle sticks bending in a weird way? Are they kind of do they look like they're gonna break in a certain spot? Can you predict where it might break if you put too much weight on it? And then reinforce that specific spot, I think, is something I always like to recommend.
All right. Looks like everybody wants to show off some bridges. So I think Frederick Douglass wants to come up and show us some bridges. We have 3 minutes left in this Q&A portion. I'm going to highlight Frederick Douglass because they've been waiting for a minute. But please do not lose this energy to show us your bridges. We are going to show you, have everybody show us their bridges during the wrap up. But Frederick Douglass, for our last Q&A pointers, I'm highlighting you, and I hear you have 2 bridges you want to share. So you are spotlighted for Bryce and Dylan to give you some pointers. Let's see your bridges. Oh, they're getting shy now. Okay, we see. Can Bryce, Dylan, do you see these 2 bridges?
Yes,
Yeah, I can see them. Yeah, and I think that those both look really, really great. I will say for the one on the left, so the one with the triangles, I would just try adding a piece on the top to kind of connect all of those triangles so they're not just freestanding, because then that will help evenly distribute that load when you do apply a load to the bridge. If those triangles are all connected, then that will definitely help make the bridge more sturdy. But I think that looks really, really great. And I love that you guys implemented those triangles, but like we kind of talked about implementing the truss design. So kind of just connecting them onto the top. But Dylan, what about the other bridge? Do you have any pointers for them?
Yeah, I think I definitely agree with the one on the left. Definitely connecting those triangles is going to make, like, if you think about it, if you have, it looks like you have 5 triangles. If you add a support on the top that's kind of across all of those triangles, it's going to double or almost double, I think, the number of triangles you have. So the more triangles you have, it's going to make it stronger. With the one on the right, it looks like you have a piece in between, like kind of in the middle of each of like the 2 triangles on either side. I think that's great. I think making sure that that bottom piece, like underneath where that kind of middle support piece is, making sure that you keep that triangle shape going on the bottom, because triangles are kind of the most important part, especially when you're going with this kind of design. So making sure that on that bottom part, maybe adding a couple more smaller pieces to make the trapezoids more into triangles. There's definitely easy ways to do that. But again, keeping that triangle design, it's going to be able to distribute the forces more than that trapezoid shape on the bottom. Because with the trapezoid shape, you're just not distributing the forces in the right way. But I think I would recommend that, and maybe some support. Actually, I don't know. I don't think you need support in the middle. I think it looks pretty good like that. Just making sure that if you put weight on it, is it gonna, like, my thought is if you put weight on it, it's gonna tilt one way or the other. So maybe putting some support to stop that top piece from tilting in the wrong direction or bending in the wrong direction as well. So kind of like what I suggested with the last,
Everybody else has like triangles on their
pressing down on the top and kind of seeing where those inconsistencies might be and where you might need to keep force.
That's okay.
All right. Well, we have run out of time for our Q&A portion, but I want to say thank you to Bryce and Dylan. But I have to say, all you students that want to show your bridges, I know there was a bunch of groups that wanted to come up. You are going to have the opportunity to go into our breakout rooms again with our mentors who are going to be there to give you pointers. And then please do not lose this energy for our wrap up where we want to see your bridges where you're going to be talking with an engineer. So again, thank you, Bryce and Dylan. Amazing job. Thank you to these students who participated and wanted to share with us so much that we ran out of time. If we can open up the breakout rooms.